Hi, my name is Priya. I'm a rising senior from Doherty Valley High School, and my main project is the planet tracker. And so for my first milestone, I connected all the hardware and verified it through Arduino. And so my first part is the motion processing unit, and the MPU 9250 includes an accelerometer and a gyroscope, and it can calculate the motion parameters of the linear acceleration, angular acceleration, and the magnetic north of the planet in reference to the object. And it has raw readings of yaw, pitch, and roll, which are the three Euler's angles, which kind of like just shows the orientation of the object. And then I also have a GPS receiver, and the GPS gives like the values of the latitude, longitude, date, and time. And the biggest challenge with the GPS is that it usually only works outdoors, and so it's just a little inconsistent with the readings. My third part was the servo. And so the servo allows like the laser to be like pointed at the right angle, and the servo's angles are dependent on the azimuth altitude calculations, which are derived by Kepler's law. And these calculations are used for like time and date. And so this is just testing it. So for like the servo, I had to use a separate voltage. I had to use a different battery because the servo needs a higher voltage than using the actual Arduino as its power source. The next part was the potentiometer, and the potentiometer uses like an analog pin and forms like a range from 0 to 1023, which is proportional to the amount of voltage being applied to that pin. And turning the potentiometer acts like a switch because it's dependent, like where the potentiometer is turned, the planet tracker will know which planet it's looking at. So the biggest challenge for this was just like getting all the pins to like work and like connecting them. Also just like having to keep going outside for the GPS. But I did learn a lot about like the basics of Arduino and like how like analog versus digital works.